In this video, we will explain how to graph this function f of x equals 3x times x minus 1 over 2x squared minus 5x minus 3. So we will start from finding the x and y intercepts. So x-intercepts, like we said before, to find the x-intercept, you want to make y equal to 0. Making y equal to 0, you will have 0 equals 3x times x minus 1 over 2x squared minus 5x minus 3. And this expression is equal to 0 if and only if the top part is equal to 0. Because if a fraction is equal to 0, the only way it is equal to 0 is if the numerator is equal to 0. So in this case, you will have only this part. 3x times x minus 1 is equal to 0. Okay, so these two are equivalent. Alright, to solve this equation, we will have either 3x is equal to 0 or x minus 1 is equal to 0. So to solve the first equation, x is 0. Second equation, x is equal to 1. So here we're looking for the x-intercept. We have two x-intercepts. One is 0, 0. The other one is 1, 0. So two x-intercepts, that's the x-intercept. Then we want to find the y-intercept. Okay, so if it is a function, there's only one y-intercept. Well, to find the y-intercept, you want to make x equal to 0. In this case, you want to find what is f of 0, which is 3 times 0 minus 1 over 2 times 0 squared minus 5 times 0 minus 3. And simplify this, well, you will see it's 0. Well, the y-intercept here is, if I mark it here, will be 0, 0, which makes sense because we have x-intercept. This is also the y-intercept. Okay. All right, we found the x-intercept, the y-intercept. Now, next, I want to find the asymptotes. I want to start from the vertical asymptotes. Okay, so maybe there's more than one. So to find the vertical asymptotes, you want to look at the denominator of the function, of this rational function. You want to make the denominator equal to 0 and try to find the zeros of this function. To solve this equation, this is a trinomial equation with leading coefficient not equal to 1. So you want to factor the first term, the leading term, and the constant term here. Factor the leading term, you will have 2x times x, that's the only option. To factor this 3, or negative 3, to factor this 3, you will have 1 times 3. I'm going to cross multiply here. This will give me 6x, and this will give me x. And what I need in the middle is negative 5x. So from x to 6x, in order to get a negative 5x, this 6x needs to be negative. So to trace it back, that means this 2x times negative 3 will give me negative 6. Okay, and I will check over here. 1 times negative 3 is negative 3. So this is the right combination. I would factor this trinomial as first row 2x plus 1, and the second factor is the second row x minus 3 equals 0. Alright, and we have two solutions. one is x equals negative 1/2, and the other one is 3. All right, so we have two vertical asymptotes. One is x equals negative 1/2. This is one vertical asymptotes. Please to include x equals this part here. If you just write negative 1/2, that's not a line. Remember, vertical asymptote is a vertical line. And the other one is the vertical line of x equals 3. Okay, so now I find the vertical asymptotes. Now I want to look at the horizontal asymptotes. Okay. All right. So now let me write down the function. F of x equals, all right, I'm going to expand the top here. I'm going to expand the top polynomial. That will be 3x squared minus 3x. That's the top polynomial. The polynomial at the bottom is 2x squared minus 5x minus 3. Okay, what I'm going to do here is divide the top and the bottom by x squared, which is the x with the power of the bottom degree, the degree of the bottom polynomial. So I will divide the top by x squared, each term by x squared. So each term is divided by x squared, and the bottom 2x squared divided by x squared minus 5x divided by x squared minus 3 divided by x squared. This will give me 3 on top minus 3 over x over 2 minus 5 over x minus 3 over x squared. Okay, I can't simplify this further. So remember, to find the horizontal asymptotes, we want to know as x goes to infinity, or the absolute value of x goes to infinity, what happened to your y value? Okay, so if your x goes to infinity, now imagine these x are really big numbers. And do you agree that this 3 over x will be close to 0? Similar here. If x is a really big number, then this 5 over x will be close to 0, and 3 over x squared will also be close to 0. So in this case, you have 3 is equal to 3 minus 0 over 2 minus 0 minus 0, which is 3 over 2. Okay, so your horizontal asymptote will be y equals 3 over 2. That's your horizontal asymptote. The next question is, will our graph f of x intersect with the horizontal asymptote, which is y equals 3 over 2. So to find if two graphs are intersecting, you want to make a system of equation. The first equation will be f of x, which is y equals 3x times x minus 1 over 2x squared minus 5x minus 3. And the second equation is y equals 3 over 2. And we want to see if this system equation will have any solution. If it does, the solution will be our intercept. Okay, so to solve this system equation, let's mark it as equation 1 and equation 2. You want to replace 3 over 2 with the y in the first equation. So you have 3 over 2, use it to replace y, equals 3x times x minus 1 over 2x squared minus 5x minus 3. To solve this equation, you can use cross multiply, which will give you 3 times 2x squared minus 5x minus 3 times, 2 times 3, that's 6, x times x minus 1. All right, let's expand this equation. We have 6x squared minus 15x minus 9 on the left side. On the right side is 6x squared minus 6x. Okay, so 6x squared and 6x squared are canceled out. Let's move negative 15x to the other side. Plus 15x plus 15x on both sides. You have negative 9 equals 9x. Divide both sides by x. X equals negative 1. So this means when x equals negative 1, there's a intercept between f of x and the horizontal asymptote y equals 3 over 2. So what is the point? Negative 1. What is the y value? 3 over 2 here. Okay. So I think we gathered enough information to graph. Let's graph our function. Coordinate plane here, first of all. X, y, 0 the origin. First, let's mark the x-intercept. We have 2 x-intercepts. One of them is 0, 0. The other one is 1, 0. So 2 x-intercept. 1 y-intercept, which is the same as the x-intercept. Now let's mark the vertical asymptotes. We have 2 vertical asymptotes over here. First one is negative 1/2. X equals negative 1/2. So it's a vertical line. And the other one is 3. X equals 3. 2 vertical asymptotes and 1 horizontal asymptote is y equals 3 over 2, which is right here. Y equals 3 over 2. Okay, then next, our graph will cross the horizontal asymptote at negative 1, 3 over 2. So let's mark it. Negative 1, 3 over 2. That means our graph will cross the horizontal asymptote at this point. Okay, now we can graph. Alright, so first of all, let's start from the 2 x-intercepts. If you go up here, your graph will cross the horizontal asymptote, which will never happen. So you have to go down here. And so since it's go down, the multiplicity for this 0 is 1, because that factor only appeared once. You connect those passing x-axis, and same here. The multiplicity for this one is also odd, so pass this one, go down here. Alright, so since the multiplicity for this vertical asymptote is also odd, how do we know it's odd? Because that only appeared once in the denominator. So do I have this part? Because one side is going down, one side will go up. For the other side, since this side is going down, this side is going up, because the multiplicity for x equals negative 1/2 is also odd. Crossing it and go, getting closer and closer and closer to the horizontal asymptote. This is the graph.